Well, hi there, thanks for tuning into my YouTube channel. Jose Quiñones, the CNC Dude here, with a continuation on our Pommel, Lightsaber Pommel project. If you recall from my previous video, I utilized the 4th axis to build this puppy here. This is a lightsaber replica. Maybe you have seen this on the Star Wars movies. This is a Luke Skywalker Return of the Jedi style lightsaber. On the second movie, he loses his Anakin style lightsaber when Darth Vader chops off his hand. Hopefully you have seen the movies. But anyway, this pommel is something that I have been wanting to do on my Tormek PCNC 1100 4th axis, because I knew that I was going to be able to get way better results than the ones I got by doing this manually about 10 years ago. And it looked like an awesome 4th axis project. So I drew it in Inventor and this is where all hell broke loose. You know, that's a typical CNC misconception, that there is a magic button that you just load up a model in your CAM software, and with a magic button, bam, right there you get your part cammed out. And this is a perfect example of a part that proved to be a nightmare to that notion because there is no way. I mean, I tried for a long time. I tried to make this with a simple single operation, and it didn't work. I sent the model for this part to different forums. I think I sent it to CNC Zone and also to Hobby Machinist, and I am positive that I also sent it to Tormek. And every time I got something that really didn't look like it was working. So I basically, every time I tried, I was so frustrated after spending numerous hours on my computer trying to get this guy to go, and I would end up shelving it just because it wouldn't. And then a few weeks ago, I saw John from NYC CNC 4th axis video, and man, there was one dinky little piece of information that just blew my mind away, and I was like, wait a moment, I know how to do this. Sure enough, I go back into Sprutcam, and like in 15 minutes I have solved the problem. So we're gonna go into Sprutcam and we're gonna see how you can do this easily. Very easy to do. It's just embarrassing how long it took to get there, but hey, that's how it works. Once you don't know how to do something, you can try all you want, but you just don't know how to do it. So once you get the information, then whammo, you're there. So I'm gonna illustrate with this part the same stuff that I'm going to illustrate in Sprutcam, but I think it's easier to understand by looking at this, okay? Let me tell you how not to do it, or how not to think that you can do it, because I tried and it didn't work. Okay, so in a part like this, we have this feature here, okay, which is basically something like a weird pocket, okay, some kind of like a 3D pocket. So you may be tempted to think, well, you know what, I'm just gonna do some kind of waterline operation, and I'm gonna let Sprutcam figure out how to use the end mill to pocket this out. Man, I tried everything that I could throw. I tried water lines, I tried pockets, contours, nothing will work, okay? So it is possible that there is a way to do it like that, but I didn't find the way to do it. And considering all the amount of time that I spent, I don't recommend you trying to do it like that. I'm gonna show you how to do this in minutes, okay? It's so freaking simple. And the idea here is to stop thinking on CAM as a magical tool to get the job done for you. You're gonna have to do a little bit of thinking here. You're gonna have to deconstruct the feature into sub-features so that you can utilize simple operations to get this done, okay? Of course, that sounds simple to say, but that doesn't necessarily solve the problem if you don't know how to do it. And that's why I couldn't do it before until I saw the dinky little piece of information from John's video, which was to adjust the 4th axis angle. Once I learned about that, then I realized, wait a moment, I can basically do this with very simple 2D contour operations, okay? So I forgot about water lines and pockets and all that jazz, okay? Now, let me tell you something else, okay? You look at a part like this, a profile like this, and you know, we may see a bunch of convoluted stuff. We have to start thinking like this modeling software, like, you know, I don't know, Inventor or SolidWorks or Sprutcam, whichever. You know, to them, this is not a Pommel. This is not a Lightsaber Pommel, okay? This is a collection of lines, dots, surfaces, faces, whatever you want to call it, okay? And to generate these features, what we have to do is generate the faces or the lines, okay? So, for example, if we start thinking like CAM now, I can see that this is one face, this guy here is another face, and this guy here is another face. I can see that this is one line, this is one line, this is one line, and so on. Okay, and yes, of course, they are repeated on the A-axis or the X-axis if you rotate it. But this is what the software sees, okay? Surfaces and lines. Once I was able to picture like that, this becomes so much easier. And once I knew about John's technique to move this in the axis. Why? Okay, so here's the problem. When I load my part, it shows up like this, okay? So this is my top, and this face is at an angle. So to tell the system to carve this face like this, man, what a freaking pain. It's not even possible, okay? It's not possible. It's gonna clash with the part, and it's just ridiculous. But hey, we're mounted into a fourth axis. The angle doesn't need to exist, because if I move this like this, okay, where is the angle surface now? There is no angle surface. I mean, it's flat, right? This is flat surface here. So all I have to do is tell Sprutcam to remove material and generate this region here. And the way that I did that was by doing a 2D contour operation and selecting this line and this line, okay? So Sprutcam is gonna go and it's gonna generate this cavity like this, okay? These faces don't exist yet, okay? On the first operation, these faces don't exist. All that I get is this flat spot, and the reason why we can now make it is because although the part starts on this position and this is 0, if I tell it to go 30 degrees, now this guy is flat, and now I can do my 2D contour operation, and I'm gonna get a flat spot, which is what I'm trying to do. Now, that's something that we have to specify manually. So, you know, you cannot just load your part like this and tell Sprutcam, hey, figure out what to do, and Sprutcam just starts rotating the part. It's not gonna fly like that, okay? You have to do that. You have to do that yourself. Luckily, some of the other stuff Sprutcam will do for you. For example, all I have to do is define how to do the 2D contour operation here. But the other 5, I don't have to define 5 subsequent 2D contour operations. All I have to tell Sprutcam is, hey, whatever you did here, do it 5 more times at 60 degrees, so you get 6 by 60 is 360. So you're gonna do it 6 times on 360 degrees. Okay, so that part, the software will compute for you. You do have to specify that you want the feature, or I should say that step in the process, and what's the spacing and how many ones you want. But you know, that's a piece of cake. I mean, it's just 3 numbers. So all you have to do is put it in. I'll show you in Sprutcam how to do it. Okay, but that's how you get 6 of these guys here, and the 4th axis will rotate the part, so you don't have to worry about that. That's the beauty of this. I mean, you don't have to be cranking anything. The machine will do it. Now, this is the easy one. This flat spot here is once we have the part at 30 degrees, this flat spot just comes out by itself. But how about these walls here? They're also at an angle, but let's remember again, we're on a 4th axis. We can change the angle, okay? So now I started thinking at this surface as a vertical wall, okay? So basically, I don't know if you can see what I'm seeing here, but as at an angle, I would need to go like millions and millions of dinky little lines to make that angle here, okay? Ridiculous. Don't even bother, because if you tilt your part like this, so that this is now vertical with respect, I mean, it's basically perpendicular to X. Now you can use the side of your blade to make that wall, okay? Once again, we have a 2D contour operation with this line. No need to worry about the angle. We can eliminate the angle because we have a fourth axis and we can specify what the angle is. And that was the piece of information that I was missing, okay? So now we can take care of this guy and we can say, hey, do it 6 times, bang, right there, complete. So if this was 30, to get to this angle, I had to go back to -15, and then to get back to this angle, because notice, if I can make this side a vertical wall, I can also make this side a vertical wall. So I went to 75 degrees, okay, which is -15 plus 90, and now my mill can go and bam, get this wall done. Do it 6 times and whammo, you get this profile, okay? Three processes, 3 2D contour operations. That's all you need to do. Forget about water lines, forget about pocketing, forget about the free Nightmare on Elm Street that this can be. If you want to let Sprutcam figure it all out, if you specify all of the parameters in order to make this a very simple operation, bam, right there. Right there. And the beauty is that you have the equipment to make this happen, because once you mount this in a fourth axis, you can eliminate the angles and make everything straight, okay? Or perpendicular to the axis. So there's still a little bit of work that we need to do, but it's really not that hard, okay? I'm gonna show it to you in Sprutcam now, how to fill out the parameters, because we still have to specify top and bottom, stuff like that. We still have to specify that. So we still have to use our brains a little bit. And of course you have to specify the angle. And I mean, maybe in 20 or 30 years the computers will just do it, okay? And then all you have to say is here. And maybe in 20 or 30 years you just say, hey, build me a lightsaber, and the computer just goes. But today we still have to input a little bit. So there's still a need for the humans to fill some forms and use our brains, and then the machines take over. And once the machine takes over, the output is gorgeous, but we still have to program them, okay? So let's take a look at Sprutcam and see how this is done with 3 2D contour operations. Alright, I am here in Sprutcam with the model that I use to generate this output, and I am showing the machine so you get an idea of how the part looks, especially how the G54 looks, because that's one of the first things that we have to do when we are defining our CAM processes. And remember, whatever you're choosing here, that's how you have to show to make on your part, or basically instruct Mach3 that or whatever software you're using, whatever controller, CNC controller you're using, you have to instruct it that this is your G54 coordinates. And if you watch the first video, you will remember that I went through great length to ensure that this side of my part, okay, this side here, let me see if I can choose different faces here. Don't know why it doesn't let me choose, but anyway, this side here it was gonna be my 0 in X, okay? And that's why I told you in that previous video that everything is gonna happen on my negative side. If I had chosen this side here to be my 0, then I would have had to tell Sprutcam that this is an offset of 2.5 inches, which is basically the length of this part. So that's for X. On Y, we did the funky thing where we touch off on this side, and then we touch off on this side, and we divide by 2, and that's my center on Y. And then on Z, notice like I explained on that video, my center is on the center of the piece, so that means that my top is at an offset. I'm gonna remove the machine now, we don't need that. One of the first things that I do when I want to start something like this is to add a cylinder around the part. And you know, for most projects I don't do this, but because I wanted to see the simulation as good as possible, I wanted to emulate the the stock. Okay, so the stock is actually 2-inch diameter. That's what I know. I have a 2-inch diameter, and I know my part from this side to this side is 1.85, so I added 0.15, which is basically the radius of 0.075. That's what I'm adding. Excuse me. I'm adding 0.075. So that's gonna make it 2 inches, and then I'm adding 0.15 to the positive and negative, and that's basically on X. But we don't need that. We don't need that that part. But definitely the other radial is the most important one. Okay, so that's basically my piece of aluminum here, and like Mr. Pete Tubal Cain likes to say, inside of this bit of material is our pommel. Okay, so we are ready to get started. Now notice that when I start, the top of my part, or my angle 0, is this. As I explained before, there's really not much we can do with this, because if I were to assign these features here, the program will go crazy, and that's that's basically how not to do it. So, and this is the piece of information that I was missing when I wanted to do this, and this is what I learned from NYC CNC. At all times, you have to specify the angle that you want the operation to take place at. And in this case, that angle is 30, okay? So notice, I'm gonna go back here to the Tormach machine. My G54 is pointing to 0. Okay, that's basically what it says here. A axis or axis A position is nothing, is 0. But on my first operation, my first 2D contouring, now I have set 30. Okay, so notice that my G54 went to 30. And now my part is gonna look like this. So now this is a flat spot, and now we can machine this by basically just removing material from this region. And the way that I specified that I wanted to remove this material was by doing a 2D contouring with these two lines. Okay, line 1 and line 2. When you specify those two lines, the system is gonna say, well, I gotta run the mill from here to here, and then from here to here. Okay, now let's look at the inside of the operation, because this is what's going to define the distances that the mill is going to traverse in Z. The X and Y are given by this guy. Okay, my coordinates and X and Y are given by my two lines. So once you select those two lines, the system knows where it needs to go. But my set, I have to specify that. Let me bring this over here. And by the way, I have selected 0.25 or a 1/4 inch end mill, 2 flutes. And just so you know, I use 5,000 RPM, 25 inches per minute. Lead in and lead out. I have a tangent approach in both cases. And then my parameter. This is the important one. Remember, my top is 1. Why? Well, because my part is actually 2 inches in diameter, but remember, my Z is my Z0 is on the center of that, so my top is 1. Now I know that I want to go to 0.75 on the bottom, because that portion of my part measures 1.5 inches. Okay, so that divided by 2 is 0.75. On my safe lane, I just choose 1.1, and I selected 4 passes, but you know, that's actually too non-aggressive. I think I'm gonna do 2 passes the next time that I build this part, because it just took too long, and I think the mill was just going easy, so I think we can do this in 2 passes. The strategy, you know, I didn't do anything here. I imagine everything is fine here. Trimming, didn't touch this. Transition, didn't touch this. Transformation, this is the crucial part. Let me go back here. When you define this guy, and when you select these 2 lines, you have basically specified how to build this feature here, but we have 6 of them. You could create 6 2D contour operations and change the angle in each one of those, but that would be pretty much demented and completely unnecessary, because Sprutcam has a feature which is basically called the multiply toolpath by axis. And I bet you've seen this before on either Tormach videos or John's videos, but basically what you say is, I want to copy my feature across the A axis, and I'm gonna do it every 60 degrees, and I want to do 6 of them. Okay, so that's 60 by 6 is 360, which means that now the software is gonna say, well, I'm just gonna take this, whatever I did here, I'm gonna do it 60 degrees after, 60 degrees after, 60 degrees after, and so on until I do 6 operations. And that's how you best utilize the fourth axis to repeat a feature that you already computed the first time. Now, this is the easy part. The second function, the second process, this is trickier. Now, what I have done in here is move my G54. Let's take a look at what I did here. I move it to angle -15, okay? And what happens is, and this is something that I computed by basically looking at my model, but when this part is at -15, this face here, now it looks like a vertical face, okay? There is, it basically, the side of the mill, and this is what I was explaining pictorially before, but the side of the mill, it just looks like the side of the mill, this face here. So all we have to do is go back and forth, and you will develop this feature. We don't need to do water lines or anything fancy like that. So yet another 2D contouring operation, and we have chosen this line, and now what we have to do is specify where we want to start and where we want to stop. This is the tricky part, okay? Where we want to stop. So if I go in, and this is where I had to do some geometry. By the way, I'm using the exact same tool, so I never stop. I'm choosing tool number 1, so there is no need for a tool change because I'm using the exact same mill, so there is no need for a tool change. Same parameters, same lead in and lead out, but in here, this is where it gets tricky. I had to do some geometry to determine where is my top level and where is my bottom level, because that line, this line here, when the part is at this angle, okay, so now if we look from here to here, this is my 1 inch, but where is this? So you're gonna have to do some trigonometry to determine where this guy is and where this guy is on Z. So this is already an offset. We are not gonna be operating on Z equals 0 here. We're gonna be operating, we're not gonna be operating on Y equals 0 or X, actually X is just defined by the line here, but the Y is going to be an offset, which the program is going to compute. I don't have to worry about that, but I do have to worry about the Z, because if I go deeper, what's going to happen is that it's going to remove some of this material, and I don't want that. I want my machine to stop right there. And this is one of the beauties of CNC, that, you know, because the computer, the machine has the resolution to go here and just say, this is it, this is my last spot. You can do this very accurately. If you try to do this by hand, I mean, with a DRO it can be done, but man, it's tricky like hell. And I don't know, I don't think I would have been able to do it repeatedly to the right point every single time. So that's something that I don't think would have worked very well. But anyway, same as before. We have here the bottom coordinate, and the quantities for, but this could have been 2, and the transformation, same stuff. Okay, we're going to define 1, but then we're going to tell the system do 6 more at 60 degrees intervals, and the project will compute everything else. Okay, so you just define 1 and it does the other 5. The last 2D contour is exactly the same, but on the other direction. So now I wanna make this guy vertical so that I can use the side of my mill, and for that, basically what I have to do is specify an angle of 75. So as you can see, what I'm doing is basically first thing on this guy, my angle was 30, then I subtracted 45, so that's -15, and now I added 45 to 30, and that's 75, and it's just basically more of the same. But this portion here, this dinky little line, is the one that made all of the difference. For many hours and days and weeks, I was pulling the hair that I don't have trying to figure out how the hell to make this feature using water lines and, you know, the other stuff that is here. If you go to create, actually it's on the other screen, so let me bring it over. These are all the processes that you have. You know, you have plane, you have water line, on finishing you have a bunch. This gets crazy pretty quick, okay? And I was expecting that some of these processes would magically carve this guy out, but that wasn't the way to do it. So 3 simple processes, 3 simple 2D contouring where you specify the line that you want, and just specify the distance instead from top to bottom, and whammo, we get our profile. So when it comes to camming, what you'll see is that you're gonna have to come up with ways to deconstruct the features that you have, so that you can make it with the different processes that we have available. This is not a 3D part, right? I mean, I guess you can consider a 3D part, but for the most part, it is basically a 2.5D, and all we have to do is play with the angles and the distances, and that's how it gets done. So it's actually it was actually fairly simple, as you can see from these super duper simple set of parameters. Okay, now let's just take a really quick look at how this thing simulates. And I think I put a little bit of, okay, actually let me go back. My apologies for that. I'm gonna go back here. Just gonna go super fast. Okay, you know what, I think I have to run this. There we go. Now we reverse it. Okay, that's our first one. Second one, sorry, first, this is the second one, and now we're doing the third one. Okay, and as I mentioned in my first video, Sprutcam is leaving some material here. Look at that. I don't know why it is doing that, but if you look at the job in slow motion, you'll see that the path is going, the tool path is what it's supposed to be. So that's why I was pretty certain that this was gonna work. But it's weird that that it would leave these little pieces of metal here. So I don't know. But by the way, when on the great majority of jobs that I have done here with Sprutcam, the output is pretty good. I mean, this is the first time that I see this stuff, so I was slightly confused as to why this was here, because I had not seen it before. But it doesn't matter because the output is good, so we know that it works, and what matters is that the toolpath is the right thing, and the output will just has to follow. All right, so look at how simple this was, and how one dinky little piece of information, which is this axis position here, how it changes the game. So anyway, this is how you can do it if you have something like this. So thank you for watching, and I'll catch you on the next video. Have a good one.